Throughout history, scientists have tried to decode the complex machinery of the brain. How do we perceive the world around us? How do we create memories, emotions, and thoughts? One groundbreaking theory that aims to explain the brain's functioning in a revolutionary way is the Holonomic Brain Theory. Developed by neuroscientist Karl Pribram and physicist David Bohm, the Holonomic Brain Theory offers an alternative approach to understanding how our minds work. Instead of viewing the brain as a simple computer that processes information in discrete bits, the theory suggests that the brain operates much like a hologram, where every part of the brain holds information about the whole. To understand the Holonomic Brain Theory, we first need to explore the concept of a hologram. A hologram is a three-dimensional image created by the interference of light waves. What makes a hologram unique is that even if it's cut into pieces, each part still contains information about the entire image. In the same way, Pribram and Bohm proposed that the brain doesn't store information in specific locations. Instead, it stores information in a distributed holographic way. This means that every part of the brain contains a holographic representation of the entire brain, just as each part of a hologram can recreate the whole image. The next key concept is interference patterns. In holography, light waves interfere with each other, creating patterns that form the image. Bohm's interpretation of quantum mechanics suggests that the universe itself may function in terms of interference patterns, a holistic, interconnected whole. The brain, according to this theory, works similarly by encoding and processing information in interference patterns. These interference patterns are thought to be the foundation of how the brain processes information. Instead of simply being a linear processor, the brain can encode vast amounts of information simultaneously, creating complex patterns that help us make sense of the world. The mind doesn't simply respond to stimuli, but integrates information from various sources in a holistic, non-local manner. Karl Pribram, one of the co-creators of the Holonomic Brain Theory, expanded upon Bohm's ideas of non-locality. Pribram proposed that the brain functions as a quantum system, where different parts of the brain are interconnected in ways that cannot be understood by classical physics alone. According to Pribram, the brain's ability to perform complex tasks like consciousness, perception, and memory might be explained by quantum phenomena. Instead of processing information step by step in a sequential manner, the brain could be interacting with quantum fields in a holistic, non-local way, much like a hologram. One of the most profound ideas in the Holonomic Brain Theory is the holographic principle. This principle suggests that the universe itself could be a hologram, and that the brain, in its ability to process information, may mirror this holographic nature. In a holographic universe, every part contains information about the whole. Similarly, in the brain, every part of the neural network may store information that reflects the entire brain's function. This allows for distributed processing, meaning the brain doesn't need specific areas to store specific memories or process specific tasks. Instead, information is encoded holistically across the entire brain. So how does this holographic model apply to our experience of perception, memory, and consciousness? According to Pribram, traditional models of brain function, where specific areas of the brain are responsible for memory, perception, or motor functions, don't fully explain how we experience the world. Instead, the brain's holographic nature allows for dynamic, fluid processing of all incoming information. In this model, memory is not stored in isolated areas of the brain. Instead, it's encoded in the patterns of interference that permeate the entire neural network. Perception is also a holistic process, where different regions of the brain interact to create a unified experience of the world, allowing us to integrate sights, sounds, and other sensory information into a coherent whole. The Holonomic Brain Theory also has significant implications for our understanding of consciousness. Since the brain is seen as a quantum system, it follows that consciousness could arise from quantum processes. The idea of a non-local, interconnected brain resonates with some of the current theories in quantum physics, which suggest that consciousness may not be confined to the brain, but could be a global phenomenon influenced by the quantum nature of the universe. Furthermore, this theory suggests that consciousness itself might be a holographic process where every part of our brain holds a reflection of our entire conscious experience. This could explain why our thoughts, memories, and perceptions seem so intricately connected, and why our conscious experience feels so unified, even though it arises from the activity of billions of neurons. An intriguing idea within the holonomic brain theory is that the brain is not just a generator of consciousness, but also a receiver of information. Pribram and Bohm suggested that the brain could be picking up non-local information from the quantum field, much like how a radio receiver picks up radio waves. This means that our thoughts, perceptions, and experiences might not originate solely from within the brain, but could be influenced by an external quantum field. If true, this would represent a profound shift in our understanding of the mind. Instead of seeing the brain as an isolated organ that generates thoughts and consciousness, the holonomic brain theory suggests that the brain could be intricately connected to a broader quantum reality, opening up new avenues for exploring the nature of consciousness itself. In conclusion, the holonomic brain theory offers a radical new way of understanding the brain. This theory, rooted in quantum mechanics, suggests that our brain functions much like a hologram, where each part contains the whole. By exploring this perspective, we can unlock new insights into consciousness, memory, and perception. We encourage you to delve deeper into this fascinating field and consider how it might reshape our understanding of the mind. Join us in this journey of discovery and innovation.